Hey everybody, Jesse Foster, aka Entranced here. I'm coming at you guys here with part 2 of the basic Bluff Odd series. I got a couple of questions on this part, and the video did not cover this section of the form, so I decided to expand it. We're going to be going over how often a raise has to work to be plus EV using the basic Bluff calculation for that, and then also going over uh, deciding the best bet size when you know how frequently your opponent will fold. Okay, so the first thing we're going to be going over is how often does a raise have to work. Calculating how often a raise has to work is very similar to calculating how often a bet needs to work. There are a couple of things that you need to consider though when you do this calculation. One is to make sure that you take into account effective stacks. A lot of the times you will be in situations where you'll be shoving and you want to take into account if your opponent doesn't have an effective stack to cover you because that will affect the math. The second thing is to make sure that in this calculation it says the current pot is the pot size plus your opponent's bet, which is already in the pot. So it's not just the raw pot size, it's including your opponent's bet. However, the equation is the exact same. The equation is amount risked divided by current pot plus amount risked equals the break-even frequency that they need to fold. So, as an example, you are playing 400 no limit. It folds you on the button, or it folds to the button, who raises to $12. The small blind folds, and you call with 2 unknown cards. The pot is $26. You check, and your opponent bets $18. You check raise to $48. How often does he have to fold for your raise to be EV neutral? So we just plug it into the equation here. $48 divided by the current pot, which is $44. We get that number by adding the $26 in the pot plus the $18 your opponent has bet for $44. So $44 plus $48, and then divide 48 into that, and we get 52%. I'll work that out in open office here. So once again, amount risked is 48. Excuse me, 48. Pot size is 44. So equals 48 divided into 48 plus 44 equals 52%. Okay, so that's fairly simple. So just go through these examples and fill them out and put your answers right here. Should be fairly simple, and if you got the first section, this should be pretty easy as well. Just remember that to make sure that you take into account effective stack sizes, make sure you double check that, and remember that current pot size is the pot size plus the opponent's bet. In this next equation, we know how often our opponent will fold. We want to calculate the bet size that will be EV neutral given the folding frequency and the pot size. What that basically means is we know how often he's going to fold. Now, what size should we bet in order for it to be an EV neutral bet? And then any bet size below that will be plus EV. So that might sound a little bit complicated, but hopefully you'll understand as we go forward. So the equation is X, and X is the break-even bet size. That's what we're trying to find. X equals the folding frequency times X, which is the break-even bet size, plus the folding frequency times the pot size. So it's going to involve a little bit of basic algebra, but it's not too complicated, so bear with me. Here's the shorthand equation. X equals parentheses folding frequency times X plus parentheses folding frequency times pot, or P, close parentheses. So for the first example, we're playing 200 no limit with 100 big blind effective stacks. It folds to us on the button, and we raise to 3 big blinds with 2 unknown cards, and the big blind calls. The pot is now $13, and the flop is ace 9 deuce rainbow. we somehow magically know, and this in poker it isn't impossible to completely know, but this is for the sake of argument. We know that our opponent will fold 50% of the time if we bet. What is the best bet size, or what is the break-even bet size? So, given that he's going to fold 50% of the time, and the pot being $13, we just plug that into the calculation. So, x equals, and we're using, just look up at the shorthand equation here, we can see we're plugging it in. X equals 50%, that's the folding frequency, times x, plus 50% times the pot size, $13. We multiply it out, and we get 50% times x is 0.5x, plus $6.5, so 50% times 13 is $6.5. We subtract the 0.5x from both sides, and we get 0.5x equals $6.5, and from there we get x equals $13. So in this situation, the break-even bet size is $13. So what that means is that if we bet any size under $13 and our opponent folds with the same frequency, then it's going to be a plus EV bluff in a vacuum. In this next example, we're going to go over a pretty common situation where this calculation can be used. So we're playing six max, we're on the button with deuce 3 offsuit, and it's folded to us. We raise the 3 big blinds, and the small blind folds, the big blind calls. The flop is king 7-5 with 2 hearts, and the big blind checks to us. We bet, and he calls. The turn is the 10 of hearts, he checks again, we bet, and he calls. The river is the jack of hearts. So now we want to decide, is a bet going to be plus EV, and how often is our opponent going to fold? So, to use this example, we have to make a couple of assumptions. The first assumption is that villain will fold all non-flush hands. This is a 4-flush board, and I think that's a pretty typical thing. Unless you're playing against people who called in extremely lightly, when you triple barrel on a 4-flush board, they generally fold without a flush. And the second assumption we make is that the size of our bet will not affect his calling frequency. You can see here that in parentheses I've put theoretically. This is not actually the case. However, for the sake of argument, we're going to treat it as such. Size of bet does affect calling frequency, but in these type of spots, such as spots where 4-flush boards, your bet size does not affect his calling frequency that much. Unless you're betting about a quarter of pot, people just generally are not going to call you with non-flush hands, period. So, those are our assumptions. Okay, so the pot size is $6.5, or 6.5 big blinds. And I have narrowed down his range here to what I think is a reasonable range for him to get to the river. Because I think he would check raise all flush draws on the flop, or check raise all his flushes on the turn. I think he would check raise all sets, and I think he would 3-bet a pretty standard value range of ace queen and pocket nines plus. So I think this is the range that he will likely get to the river with. And we can see, using Combinator here, that given those assumptions, he only has a flush or better 25.5% of the time, and he has 2-pair or worse 74.5% of the time. So given that our opponent is going to be folding 74.5% of the time, that's our folding frequency right there, 74.5, and we'll enter that as a percentage. I have to redo that. Okay, 74.5% of the time. Now we need to calculate our break-even bet size using the equations. So we're solving for x, and we are looking for x equal, we just use this equation here, so x equals the folding frequency, which is 0.745 times x plus 0.745, the folding frequency once again, multiplied by the pot, which in this case is 40. So we multiply out in both of those, so we get x equals 0.745x plus whatever that is, 0.745 times 40, we get 29.8. Okay, and so now we need to get all the x's on the same side of the equation, and we will get, by subtracting 0.745 from 1x, we will get 0.255x equals 29.8. And so next what we need to do is just divide both sides by 2.55 so that we just get x on one side. So we take this number, 29.8, divide that by 0.255, and we get 116.8 is our break-even bet size. So in this case, this is our number right here. Given these assumptions, we can bet $116 into or 116 big blinds into a 40 chip pot and be a neutral EV bet. Now, that does not mean that this is the correct bet size. This is just stating what is the break-even bet size. Given that he will be folding regardless of our bet size, we should actually be betting much smaller, something actually like 15 big blinds. But using this tool, we can see that given that his folding frequency, we can bet a pretty huge amount here, and it will still be break even. Now, if we were to change this and look at different folding frequencies, let's say his folding frequency would be 25%. Okay, so we plug it in once again. X equals, so X equals the folding frequency, in this case 0.25, multiplied by X plus 0.25, the folding frequency, multiplied by the pot size. So we multiply out once again, we get that X equals 0.25x plus 0.25 times 40. I know offhand that that is 10. Okay, and then once again we subtract 0.25x from both sides. Subtract 0.25x from 1x, and we get 0.75x equals 10. And then we just multiply or divide both sides by 0.75, and we get equals 10 divided by 0.75. In this case, our break-even bet size is 13 big blinds. So, in this situation, if our opponent were only had non-flush hands 25% of the time, we could bet 13 big blinds or smaller, and it would be a plus EV bet. So I hope this has explained this well. This is not trying to find the most optimal bet size. This is just finding the break-even bet size, and then we work from there. If we bet anything smaller than the break-even bet size, our bet is plus EV. Okay, so I hope you've enjoyed this, and I'll see you guys later.